clients.
So welcome to chemistry class. This is the electrochemistry. So we start from the reactivity series. Good afternoon.
Good afternoon, sir.
How are you?
We are fine, thank you, sir.
I'm also fine. So we can continue from where we left. I request you to give me the order of reactivity series, how metals follow each other in terms of displacement. In terms of displacement reactions. So I need someone who is going to give us that series. How the metals follow each other in terms of decreasing reactivity from the top to the bottom. Let us. At the top we have potassium. On the top we have potassium followed by sodium. Sodium whose symbol is N, capital N, small a. We have calcium. Calcium we have capital what? Capital C, small a. We have magnesium. Magnesium, capital G. We have aluminium. Aluminium is Al. Al. We have zinc. Z. N. N. We have iron. Iron is ferrous. Fe. We have lead. Lead from plumbum. Pb. We have copper. Copper from cuprum. C. U. We have silver. And silver, which is J-dam, which is Ag. So that is the order. If our arrow is going to point up, then it means it is order of increasing reactivity. Order of increasing reactivity. So here this is increasing reactivity. So in summary, we were saying, for example, if we can consider two metals like calcium and magnesium, if we can consider calcium and magnesium, I would like someone to tell us, will calcium displace magnesium from its solution? Calcium, will it be able to displace magnesium from its solution? Sirere?
It can displace magnesium from its solution because it is high in the reactivity series.
So, Sirere is telling us calcium will displace magnesium from the what? Its solution because it is at a higher point in the reactivity series than the magnesium, which is good. Give him a clap. Okay. So, for example, if calcium is going to enter into solution, then calcium will be now the solid. In this case, for example, we are going to use the powder what? The powder form of calcium. Then magnesium will be in solution. Like for example, we can have any soluble salt. Any soluble salt like a sulfate. Is magnesium sulfate soluble salt or not? Is it soluble? Yes. So if it is soluble, we are going to have magnesium sulfate. In solution, it is going to be what? Aqueous. And that is to mean we have existence of magnesium being what? Ionic, because magnesium loses 2 electrons, we are going to have 4 plus. And then we have also existence of what? A sulfate there. So this is what we are interested with, because it is the what? It is the metal we are interested with. So when we talk about displacement reaction, and this calcium is able to displace magnesium from its solution, the solution in which it is, then it means calcium entering into solution will now gain electrons or lose electrons. Onesimus, will calcium gain electrons or lose electrons when it goes into solution? Remember here it is in solid state. Will it lose electron or gain electrons when it enters into solution? It will lose electrons. One clap. Okay. So calcium will enter into solution as solid but it is going to lose electrons. How many electrons does it lose? How many electrons will calcium lose? Kenneth? 2. One clap. So calcium is going to lose 2 what? Electrons. So it is going to become calcium 2 plus, because it is a metal. All metals react by losing electrons to become positively charged. And then we balance the equation by writing the electrons it has lost on this side. So that we have 2 electrons plus 2 electrons plus the 2 electrons which had been lost, so that it can reach its original state of being a solid. So that way, magnesium here was in which state? Ionic state. So this is now the first half equation. That is the half equation. In the second half equation, magnesium was in ionic state. So magnesium was 2 plus. Which means it is deficit of what? 2 electrons. So for it to reach original state or stability, or to go back to the atomic state, it has to gain 2 electrons. It will gain 2 electrons which have been lost by calcium. So we are going to have magnesium 2 plus 2 electrons. For it now to have what? To balance the electrons it has lost, to reach octet configuration. And on the other side now, it is going to be what? Magnesium in the solid state. This one is in aqueous state. This is solid state. This one is aqueous state. So that is now the second half equation. So from there, we write now the overall equation. How do you write the overall equation? You combine the what? First half equation and the second half equation. So we consider what is main in the first equation. Here we have calcium on the side of the reactants. So on the side of reactants, we have calcium in solid state. In the second half equation, what we have in the reactant? Someone to lift your hand and tell me, in the second half equation, what we have in the reactant side. This equation now, what do we have in the reactant side? On the side of the reactants, what do we have? On the side of reactants, what do we have? Simon? Magnesium ions. Good. What else? We have magnesium ions on the side of reactants. What else is on the side of the reactants side? What are you able to see in this equation? Yes, my own. Electrons, isn't it? So whatever is here, we write it on this side. But now you are going to notice that here we have electrons on the product side. Here we have electrons on the what? So these electrons will like cancel out. So we are not going to consider them in the overall equation. What we are going to write it is only here magnesium. So we have plus magnesium 2 plus. This one is aqueous. And when you are writing these symbols, make sure that they do not touch one another. The moment they touch one another, you will do what? You will disobey the high-impact nomenclature and the equation will be wrong. So you have calcium solid state, magnesium ionic state, giving us the product. What is the product in the first half equation? Which product can you see in the first half equation? This one, the product which you are able to see. Colin, on the side of the products, what are you able to see here on the first half equation? Yes, John Bosco. Calcium ion. So we have calcium ions, which is an aqueous state, plus we go to the second half equation. What can you see on the product side? What can you see on the product side? Grace? Magnesium. Yeah, she is right. If she says just magnesium, it is okay because it is in atomic state. But if it was ionic state and she says what? Magnesium, then it would be wrong. Unless she says what? Magnesium ions. So that is now what we call the what? Overall equation for that area. For that reaction. That is the overall reaction equation for that reaction.